Hello, my name is Frank McKenna. I'm here at UC Berkeley working for the Near East Sim Center. In this video, we're going to review two of the examples we presented yesterday that use pointers. The reason we're doing so is that it's very important you understand pointers if you ever to write efficient C code. So again, a pointer variable. What is a pointer variable? A pointer variable is a named memory location that holds an address. Yesterday we saw variables of type integer and floats that held ints and floats. Well, a pointer is just another type of variable, and this type of variable holds addresses in memory. So to hold an address, we basically first have to define a pointer variable. To define a pointer variable, we use the star symbol. So a star symbol before the pointer variable says that this variable, pointer x, is of type pointer. It's actually a pointer to an integer. And what we're doing in this statement is we're assigning that pointer x to have the value 0. So we're saying that pointer x is a pointer, it points to a type of integer, and it has a value equal to 0. So in memory, after these two statements have been executed, we're going to have a variable x, it's going to have the value 10. We're going to have an uninitialized variable y, so it's just going to be considered dribble. And we're also going to have a pointer x, a variable pointer x, which has the value 0 at this point. It's very important when you create pointers, you assign them to have the value 0. That way you will know, because the program will crash if you ever try and dereference an initialized pointer that's been initialized to 0. If it is uninitialized, it might point to some random memory location, which might be okay. So the program will actually keep running, and it'll give you crazy errors that are very, very difficult to track down. Next up, we want to use the ampersand. The ampersand is used to, we want to set the value of what the contents of that memory location. So to get the memory location of our particular variable, we use ampersand x. That will return the address of where x is. And what we're going to do is we're going to send pointer x to have that value. So here we're setting pointer x to have the value equal to the address of x, which I just said is equal to this random number. So we say pointer x points to x. It's actually pointing to the first byte of x. Remember, x is 4 bytes long, so we'll actually point to the memory location of that first byte. Next up, we're using the assignment to point a star. In an assignment, if it's on the right-hand side of the assignment, we're saying use the contents of whatever this is pointing to in the expression. So in this case, whatever pointer x is pointing to, pointer x is pointing to x. So we take whatever that value is 10. 10 plus x, 10 plus 10 is equal to 20. So we're assigning y to have the value 20. If we have the star on the left-hand side of the assignment, we are saying to set whatever pointer x is pointing to, which is x, we want to set that equal to 50. So we're setting whatever pointer x is pointing to, we're setting it equal to 50. So this is like saying x is equals to 50. So that was the first problem we presented yesterday on pointers. We also used pointers in a second example when we were iterating through arrays with pointers. Let me remind you of the program. We have our preprocessor definition, where we're including standard I/O. We're defining the function ahead of before we use it. We have our main function here. The main function, argc argv, it returns an integer. Inside the main function, we're declaring a variable of type int array. It's 6 long, so we have 6 variables. We're assigning them, initializing them to the values 19, 12, 13, 14, 50, and 0, as we'll see right here. Then we are creating a variable sum1, and we are initializing it to the result of sumArray. So sumArray is this function. Then we're taking whatever sum is and we're putting it into this statement, and we're putting this string out. So here is the function sumArray. It takes 2 arguments, data pointer and size. Data pointer being a pointer to an int, and size being an integer. And the function is going to return an int. Inside the function, we're initializing a variable sum to have the value 0, and then we loop in a for statement over that array, setting the sum equal to the current sum plus whatever data pointer is pointing to, and then we increment data pointer by a certain amount. So let's go through what this does in memory when we first invoke this function. So this is our stack. We've added a function to this stack. This function has 4 variables, so we get 4 variables added to the stack. We have data pointer, which is pointing to the address of, which is given the address of whatever int array was, which int array is this. So data pointer contains this address. We're passing in size. Size is 6, so there's 6. We're initializing, so we have some variable sum, it's initialized to 0. And then we have another variable I, which is initialized also to 0. So when we loop through this function, we're going through this for statement. Let me show you exactly what the state of the memory is at this point right here. So here we are at this point when in that first time we're in the loop, I is equals to 0. Data pointer is still pointing to the first element of the array. The value of what it's pointing to contains the number 19. So sum equals sum plus 19, which turns it equal to 19. Next up, we increment the pointer by 1. Data pointer plus plus increments it by 1. So now we've incremented data pointer. Data pointer is now pointing to 12. So we do sums equals sum plus 12, should be equal to 31. Now you might ask, when I incremented it by 1, how come it went up by 4? So it's gone up by 4 values here. It's gone from 2 to 6. That's because the compiler knows that we're pointing to an integer. The compiler knows that integers are of size 4, so it knows to increment the data pointer by the amount of 4. That's why when we define a pointer, we actually tell the compiler what type of variable it points to, so the compiler knows in pointer arithmetic how to increment the values. So next up, we're 2. Again, we've incremented by 4. Whatever pointer to, it's actually now pointing to 13. We add 13 to sum and we get 44, and so on through the thing. And I'm just showing these numbers. The OX means we're printing out the numbers in hexadecimal. And for those of you who want to forget, this is how the hexadecimal goes. It's basically 16 values are represented. I thought I'd just demonstrate those. You can actually get them from the program. So I'm in SimCenter Bootcamp code C. That example I was looking at was function 3, so I'm going to edit function 3. So I'm going to emacs function 3.c. There's our int sum array. Here's our main function. This example actually takes 2 arrays. So we have an integer array called int array 1, where we have our 19, 12, 13, 14, 15, 0. So I'm going to keep that one, get rid of int array 2. We're going to change the output here. Let's say sum is %d, it's sum1. So here's our sum array function. I modified it slightly. So instead of data pointer, I've called it data here. So let's just and you'll also note, here's an interesting one I did. I put I incremented the pointer inside in the for loop in that increment phase. So I didn't have this data pointer plus plus down here. So I don't have this, I put it up here. Let me just regurgitate what I did in that video demonstration. So I'm going to take it out of here. And what I want to do is print out the values at this step here, like I showed in the video. So I was spitting out I was spitting out the pointer. So we see this is new. So %p, we want to print out a pointer. %d, we are pointing out what the pointer pointed to. And finally, we're printing out sum. I'll do a new line. So we're printing out I. We're printing out data pointer. We're printing out what data pointer points to. And finally, we're printing out sum. Okay, so this should hopefully compile. So let me GCC this. Function 3. Okay, so I've compiled it, and now I'm running it with the a.out. So here's my eyes, 0, 1, 2, 3, 4, 5. Here is my pointer values. So data pointer, initially it has the value D0, D4, D8. So you see it's going up by 4 every time I increment by that plus plus. These are what the values that they're pointing to. And then this is the value of sum, and that should be as I've shown in the table. I will point out in my figures I do not show the full, all the digits that would be in a hexadecimal address. It's quite long and I just need to shorten it. But that's what the actual address is being spit out of a 64-bit application. So with that, I'm done with this video. We'll go on to the next. Before I go on to the next, let me show you a little Git feature. Say I really don't like the change I just made. I want to leave that thing alone. I will just throw away all the changes I just did by invoking the command git checkout function 3.c. So this will change the file now to be as it was before I started editing it. So let me show you what I'll cat the file just to show you. And as you see, that is my original file back again. The advantages of Git. So with that, we'll close the video.